Hello everyone, I'd like to welcome you to this video titled Equivalent Ratios. Now what I would like for you to do is get out your Math in Focus book and turn to page 183. And we're going to go ahead and take a look at equivalent ratios. And the goal for this video is for you to understand how to write equivalent ratios, write ratios in simplest forms, and also comparing ratios. So the first part that we're going to look at is being able to write equivalent ratios to show the same comparisons of numbers and quantities. So if we take a look at the Learn section on page 183, it says that Emma has 8 red marbles and 12 blue marbles. Okay, so we know that the ratio number of red marbles to blue marbles is 8 to 12. So you can see 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blue marbles. So 8 red, 12 blue. Now, if Emma groups 2 marbles of the same color into each group, you can see that now the ratio is 1, 2, 3, 4 red marble groups to 6 blue marble groups. So we can see that the ratio of 8 to 12 is equivalent to 4 to 6. So let's turn to page 186 and let's practice this together. Okay, so you can see on page 186, first of all, we can see the number of pencils to the number of erasers. So we have 10 pencils. So right here, so 10 pencils, and we have 20 erasers. So the ratio is 10 to 20. Now let's take a look at an equivalent ratio. So if we were to group the pencils in the groups of 2, erasers into 2 groups of 2, so 5 groups you can see of pencils, 10 groups of erasers. Now you can see the ratio of number of pencils to erasers is 5 to 10. Okay, so let's look at what's happening. So we had 10 to 20, and that's equivalent to 5 to 10. So what you could see is that the number of pencils was divided by 2, giving us 5, and therefore whatever you do to one quantity you have to do to the other, divide by 2, and that gives us 10. So that's an easy way to find equivalent ratios, is divide both quantities by the same number. So let's take a look at the next one here. 1 group of pencils total, 2 groups of erasers, so 1 group of 10, 2 groups of 10. The ratio is 1 to 2 there. Okay, so let's jump on down to number 4. We can look a little bit more specifically at what I was talking about a little bit earlier. So when we have 10 pencils, 20 erasers, we divide into groups of 2, which would give us 5 groups of 2, and then 10 groups of 2. 10 pencils, 20 erasers divided into groups of 10, 1 group, and then we could see there'd be 1 group of 2, and then for the next one here, we could see 2 groups of 2, okay, into 10. So what we can see, the ratios of 10 to 20, 5 to 10, and 1 to 2 are all equivalent ratios. So again, what we're doing here, we're dividing both quantities here by the same number. In this case, divide by 2, and that gives us 5 to 10 is equivalent to 10 to 20. You can either do it the other way, also do it the other way around, multiply both quantities by 2, and that's a way to get an equivalent ratio that way. Divide both by 10, it gives us a ratio of 1 to 2 is equivalent to 10 to 20. Or you can multiply both by 10, and they can give you 1 to 2 is equivalent to 10 to 20 as well. So now we're going to just practice finding equivalent ratios by division. So what we can see here, what I was talking about, use division to find all whole number ratios equivalent to each of the following. So let's take a look at number 1. And we can see that this is on page 188. So you can divide both numbers. It has to be a number that goes into both of them. So we're going to divide both 18 and 27 by 3. 18 divided by 3 is going to be 6. 27 divided by 3 is going to give me 9. So the ratio of 6 to 9 is equivalent to 18 to 27. Now let's say I divided both numbers by 9. We do 18 divided by 9 is 2. 27 divided by 9 would be 3. So again, whenever you're finding equivalent ratios using division, you must divide by the same number. Now let's take a look at the next one, state whether each pair of ratios is equivalent. So if I go 7 to 8 and 8 to 7, that is not equivalent. Now let's say 1 to 3 and 5 to 15. So let's think about, what do we do to 5 in order to make it a 1? We divide it by 5. That gives us 1. 15 divided by 5 gives us 3. So that would be equivalent there. So again, what you need to do is just understand that you divide both quantities by the same number. When you do that, you get an equivalent ratio. Now let's turn our books to page 189, and let's take a look at practice using greatest common factor to write ratios in simplest form. So think about ratios as fractions, and just like you would reduce a fraction to simplest form, you want to do the same thing with ratios. So we have the ratio of 12 to 64. And the first thing we need to do is we got to figure out the greatest common factor, GCF, of 12 and 64. Now the greatest common factor of 12 and 64 is going to be 4. So what we're going to do is we're going to divide both numbers by 4, and that will give us this ratio in simplest form. So we take 12 divided by 4, that's going to give me 3. 64 divided by 4 is going to give me 16. So we have the ratio of 3 to 16, which would be equivalent to 12 to 64, but 3 to 16 is in simplest form. Now let's take a look at 2 kilograms to 21 grams. First of all, we need to convert this ratio because we have kilograms and grams. All right, so the 7 kilograms is going to be 7,000 grams. And the 21 grams will just stay as 21 grams. So the ratio is 7,000 to 21. Now what we need to do is we need to find the greatest common factor of 7,021. All right, so we don't need to go through 7,000 necessarily, but we need to understand that 21 has a factor of 7. We know 7 can go into 7,000. So that means what we will do is we'll divide both parts of our ratio by 7, the greatest common factor. All right, so we have 7,000 divided by 7 is going, let's just write this in here before we get started here. 7,000 divided by 7. And we're also going to take that 21 and divide it by 7. So again, we're making this into simplest terms here, or simplest form. 7,000 divided by 7 is 1,000. 21 divided by 7 is 3. So we have 7,000 to 21 in simplest form is 1,000 to 3. So again, what we do, we find the greatest common factor, divide both parts of our ratio by the GCF, and that gives us our ratio in simplest form. Now let's turn to page 190. We're going to take a look at practice finding the missing term in a pair of equivalent ratios. I know there's a lot of topics in this video, but we're going to take a look at this one here. So let's take a look at number 1. So we have the ratio of 48 to 64 is going to equal what to 8? So what we need to do, first of all, we're going to be either dividing or multiplying to find this missing term. Okay, so think about the 64. What happened to 64 in order to get it to 8? Okay, so they divided. Okay, how do we know? Because the number did get smaller there. Okay, so if we take 64 divided by what number gives us 8, so it's going to be 64 divided by 8. Okay, so if we divide 64 by 8, we need to divide 48 by 8, and that's going to give us 6. So the missing term would be 6. So that would make the ratio 6 to 8. So that's dividing. Now let's take a look at multiplying. So let's number 3. That second term is the one that we can see it's changed. We don't know what the first term is. So what happened to 5 in order to get it to 35? It was multiplied by 7, because 5 times 7 is 35. Since we multiplied one term by 7, we have to multiply the other term by the same number. 7 times 7 is going to give us 49 there. Okay, so we have division for number 1, multiplication for number 3. Just remember, you have to do the same, either multiplying by the same number or dividing by the same number of each term in order to find that missing term. So we will go over other topics as we take a look at equivalent ratios, but this gives you a pretty good foundation of what goes into equivalent ratios. Just understand that it's important to know that you need to divide or multiply both terms by the same number in order to get that equivalent ratio. If you have any questions about this concept as you're working through these problems, please come and see me.